Hello everyone, and welcome to our group's project proposal. We are Group 10, and my name is Dempsey, along with my teammates Carlos Romero Romero, Derek Shin, Garen Atsrounian, and Fabricio Reyes. Today, we're excited to present our project on AI in video games, intelligent NPCs, and opponent learning. We'll be exploring how artificial intelligence is transforming NPC behavior, making games more immersive, dynamic, and unpredictable. Our project will focus on understanding and implementing AI-driven opponent learning through simple coding and flowcharts inspired by games like Alien Isolation. Throughout this presentation, we'll break down how AI is used in video games, how it learns and adapts, and how we plan to apply these concepts in our own project. Let's get started. If you are watching this video, either you are an AI enthusiast or at some point enjoy video game. Now imagine playing a game where NPCs actually learn from your actions, adapt to your strategies, and even remember past interactions with you. Sounds like sci-fi, right? Well, it's happening right now. Back in the day, NPCs were simple. They followed pre-scripted paths, had limited dialogue, and barely reacted to players. You probably remember running into NPCs who repeated the same line over and over again. But today, AI-driven NPCs are evolving. They can react dynamically, remember your choices, and even learn from player behavior. The biggest shift, AI in video games is no longer just about pre-programmed scripts. It's about intelligent agents learning and adapting in real time. Take the xenomorph from Alien Isolation, for example. It doesn't just follow a path, it hunts you. It learns, adapts, and reacts to your actions in unpredictable ways, making every encounter terrifyingly unique. When we think about NPCs in video games, we expect them to make the world feel alive. But how realistic are they, really? Imagine walking into a restaurant in a game. You see an NPC eating food, but look closer. Is the food actually being eaten? Or is it just a visual illusion? On the left, Red Dead Redemption 2. Each bite the NPC takes actually reduces the food on their plate. On the right, Cyberpunk 2077. The NPC is eating, but the food never changes, making it feel less immersive. This small detail highlights a bigger problem. Most NPCs in video games aren't truly intelligent. Their actions are often scripted, repetitive, and predictable. But with advancements in AI, that's starting to change. In older games, NPCs felt static. They repeated the same lines, followed the same patterns, and had no memory of past interactions. This was because their behavior was entirely scripted, with no real ability to change or learn. For example, in Skyrim, you might hear this sentence from many NPCs dozens of times.
I used to be an adventurer like you. Then I took an arrow in the knee.
I used to be an adventurer like you. Then I took an arrow in the knee.
I used to be an adventurer like you. Then I took an arrow in the knee.
You can see that the NPC isn't actually thinking, they are just running a preset dialogue tree. Now imagine an NPC that doesn't just repeat dialogue, but instead remembers previous interactions, reacts based on player actions, and even creates new responses in real time on the player's progress in the game, like in Red Dead Redemption 2, when you have taken out one of the NPC's husband.
You killed my husband! You evil bastard! Now I have 3 babies to raise alone. 3! Who is going to take care of our family now?
I'm sorry about your husband, lady, but I don't know what you're talking about.
You heartless bastard!
Here, listen, it ain't much, but take this.
You think this absolves you?
This is the shift we're seeing with AI-driven NPCs. Games are starting to experiment with this concept, using advanced AI models that generate dynamic conversations instead of pre-written lines. This is where transformers and large language models come in. Instead of relying on a developer to write every possible response, LLMs allow NPCs to generate unique context-aware dialogue in real time, creating conversations that feel natural and unscripted. By understanding the relationships between words, transformers can process and predict dialogue, just like we see in AI chatbots today. This means future NPCs could not only interact more realistically, but actually learn and adapt, much like AI opponents do in modern games. Through our class, we've probably heard of GPT models, AI systems that generate human like text. These models are built using transformers, which are deep learning architectures that process and generate text contextually. Transformers work by understanding the relationships between words and predicting the most relevant next word based on context. This same concept is being applied to NPCs in games. With advanced AI technology, specifically based on transformer neural networks, modern games in these days can create more dynamic and responsive NPCs with improved dialogue and interactions that can adapt to the player's actions and the game world situation, essentially making them feel more natural and engaging as shown in Red Dead Redemption. On the other hand, games like AI Dungeon use LLMs to generate unique, unscripted dialogues, creating interactive storytelling experiences where no two conversations are the same. By combining transformers and LLMs in NPC behavior, modern AI could create NPCs that dynamically react to the game world and beyond just animations where NPCs will feel more human, making gaming worlds richer and more immersive than ever before.
Think about the last time you played a stealth or combat game. Was the enemy AI predictable, or did it actually feel like it was adapting to your strategies? In early games, enemy AI followed static patterns. They'd patrol, chase when spotted, and return to their routine if you hid long enough. But today, AI opponents are getting smarter. They learn, adapt, and even strategize against players. Take the original Metal Gear Solid. Enemies had fixed patrol routes and basic alert mechanics. If you hid for a few seconds, they'd forget you existed and return to normal. Compare that to The Last of Us Part 2 or Alien Isolation, where enemies actively search, call for reinforcements, and respond dynamically to your tactics. These aren't just scripted behaviors, they use AI learning systems. Before we dive into learning AI, let's first look at how traditional enemy AI works. Most games rely on combination of finite state machines and behavior trees. A finite state machine works like a flowchart. If the player is seen, the enemy switches from patrolling to chasing. If they lose sight, they switch to searching, and after some time, they go back to patrolling. Behavior trees add more complexity. Instead of just switching states, they allow AI to evaluate multiple conditions and choose actions dynamically, leading to more lifelike decision making. But while FSMs and behavior trees make enemies seem smart, they're still rule-based, meaning they don't truly learn. That's where AI learning systems come in. Modern games are moving beyond pre-programmed enemy behaviors and using machine learning techniques to create adaptive opponents. In Alien Isolation, the xenomorph doesn't follow a preset path. Instead, it learns where the player hides, making each encounter unpredictable. This is because the game uses a two-layer AI system: Director AI, which is a high-level control, and behavioral AI, which is low-level reactions. Another example is Dota 2's OpenAI 5, a reinforcement learning AI that played millions of matches to develop strategies that even pro players struggle to beat. In The Last of Us Part 2, enemies coordinate, flank, and react to player strategies. This isn't random. It's powered by advanced AI behavior modeling. One of the most exciting advancements in opponent AI is reinforcement learning. Instead of relying on a hand-coded behavior, reinforcement learning lets AI train itself through trial and error. In reinforcement learning, the AI agent takes an action, gets rewarded for good decisions, like finding the player, and penalized for bad ones, like losing the player's trail. Over time, it optimizes the strategy. Using reinforcement learning, AI opponents can become less predictable, making each playthrough unique. As AI technology evolves, we're moving towards opponents that think more like real players. Imagine a future where an enemy in stealth game not only remembers where you hid, but also predicts where you might go next, forcing you to constantly adapt. With reinforcement learning, neural networks, and transformers, the next generation of video game enemies won't just react, they'll strategize, learning and evolve alongside players. Now, let's look at how AI NPC learns in modern NPC interactions with reinforcement learning and neural networks.
When we play against AI opponents in video games, we often think that they're just following a set of rules, but modern AI systems go far beyond pre-programmed behaviors. They can learn, adapt, and even predict player actions. Old AI relied on fixed patterns. The Ghost and Pac-Man always followed the same set of behaviors. No learning, no adaptation. But today, AI agents in games use advanced reinforcement learning and neural networks, allowing them to improve over time just like a human player would. Reinforcement learning, or RL, is a type of AI training where an agent learns through trial and error. The AI tries different actions, receives rewards for good moves and penalties for bad ones, and over time, it optimizes its strategy. One of the best examples of this is OpenAI 5, an AI trained to play Dota 2 at a professional level. It learned by playing millions of matches against itself, continuously refining its strategies based on Markov's decision processes, MDPs, and deep Q networks, DQNs. Similarly, DeepMind's AlphaStar uses reinforcement learning to master StarCraft 2, predicting enemy moves and adapting mid-match, something traditional AI struggles to do. Even in single-player games, RL-based AI can improve enemy behavior. The Xenomorphs in Alien Isolation learns where players hide and changes its hunting strategies accordingly. This ties directly into what we've learned in class: Markov decision processes, MDPs, Q-learning, and deep Q networks, DQNs, form the foundation of RL, helping AI make optimal decisions based on rewards and experience.
Now that we explored how modern AIs power NPC behavior and opponent learning, let's talk about how we're implementing these ideas into our own project.
Mentioned, the Xenomorph is relying on a behavior tree architecture for controlling its behavior. In previous developer talks and in my own video, it was highlighted that this was a rather large behavior system. Thanks to Filer's mod tools, we can actually look at it and spot specific aspects of its behavior. However, it might be a little hard for you to see in the video. You see, the Xenomorph has 36 branches it can take from the root of the tree. This ranges from attacking the player to investigating disturbances that its sensors have detected, climbing in and out of vents, and fleeing from fire. But also some special tools and other secrets that hint at cut content from the game. In addition, Filer's tools expose several of the alien's sensory systems which are alluded to in the behavior tree, giving us a richer and more comprehensive view of the Xenomorph's behavior.
Our inspiration comes from Alien Isolation's AI system, which uses a two-layer AI model: a director model that controls the enemy's high-level decision-making, and a behavioral AI that handles movement, tracking, and attack behaviors. And we're not just studying AI theory, we're building a working model, and our goal is to simulate an AI that actively hunts the player just like in Alien Isolation. For our project, we explore 3 different technical approaches. The first one being the game engine prototype. It will be a simple AI enemy that searches for a player using FSMs and pathfinding. The second approach that we will be tackling will be the reinforcement learning training, which is an AI model that learns to navigate and track a player over time. And we will be looking at some Unity ML agent toolkits to help ensure that the AI is able to train and learn how to read player movement and data. And lastly, the third approach we are tackling on is the AI flowchart and the FSM breakdown. In simpler terms, it's basically how the AI reacts to players and their movement, whether it be guarding against the player's attack, whether it be moving towards the player's location, and etc. etc. Here's a simplified breakdown of how our AI will work. When the AI is in its patrol mode, it follows a random path. Once it detects movement or sound, it switches to search mode, investigating the last known position of the player. If it finds the player, it moves into chase mode, and if it loses sight of the player, it begins a calculated hunting strategy rather than returning to a fixed patrol. This is inspired by how Alien Isolation's Xenomorph searches without ever following a fixed path, making encounters feel unpredictable and terrifying. We are using either Unity with C Sharp, Unreal Engine with Blueprints or C++, or Python PyGames. And the key components of our AI system will be pathfinding, which will allow the AI to use a algorithm or a nav mesh in Unity to navigate the game environment. A sensing system, which the AI will be able to detect movement and sound through raycasting or proximity checks. A finite state machine, which controls AI state transitions between patrol, search, and chase modes. And if we are using reinforcement learning, the AI will be trained using deep Q networks to improve hunting efficiency. As we continue development, here's what we will be focusing on. We are going to be enhancing the pathfinding of the AI to where the AI is able to avoid any obstacles smoothly. We will be fine-tuning the detection logic to make sure that the enemy vision and sound detection seem more realistic. And if we are using reinforcement learning, we will be testing for adaptive learning to see if the AI will improve search patterns dynamically. And lastly, we will be polishing and optimizing the game to ensure that there are no bugs and performance and efficiency persists throughout the entire game. By our final presentation, we aim to have an AI opponent that not only reacts to the player, but also learns and adapts, bringing the challenge and unpredictability of modern AI-driven NPCs into our own project.
So AI in gaming has come a long way, from simple scripted NPCs to intelligent enemies that adapt to player behavior. But where is it heading next? The future of AI in video games is about more than just smarter enemies. It's about creating living, evolving game worlds where NPCs remember, react, and even generate their own stories. Imagine an open world game where every NPC has unique conversations, remembers past encounters, and reacts based on the way you treat them. This isn't just science fiction, it's a direction gaming AI is actively moving towards. We're already seeing a glimpse of AI-driven immersion in modern games. For example, in Red Dead Redemption 2, NPCs remember if you rob them, help them, or ignore them, and they react differently based on past encounters. Future AI could really take this further. For example, tracking long-term relationships with NPCs across entire playthroughs.
Well, look at that fancy haircut, Mr. Morgan. Who are you trying to impress?
Don't you start. How's it going, Sadie?
What's this new haircut? You look like an accountant.
Ah, shut up.
AI is also being used to generate game worlds dynamically. No Man's Sky creates entire planets, creatures, and ecosystems using procedural AI. In the future, AI could generate entire storylines, quests, and dialogue unique to each player. But with these advancements, there are also challenges and ethical concerns. One challenge is adaptive difficulty. While AI that adjusts to a player's skill can be great, it can also lead to a lot of frustration. Imagine an enemy that learns so well that it becomes impossible to beat. Some players want a challenge, but others prefer a balanced experience. Another concern is whether AI could replace human game designers. AI is already being used to generate quests, characters, and levels, but should it replace creative storytelling? Many argue that AI should be a tool for designers, but not a replacement for human creativity. The challenge isn't just making AI smarter, it's making it engaging, balanced, and ethical. So, what does all this mean for the future of gaming? AI is really making NPCs more dynamic, allowing them to react and remember like real people. AI generated content is also changing how games are designed. creating worlds and quests on demand. Something that we're able to take from this is balancing AI-driven gameplay can be a challenge. It can be made too difficult, leading to frustration, or making it really easy at times and making it feel unrealistic. The most important thing we should take from this, though, is that human creativity will always be needed. Even though the role of AI in the game world will continue to grow. It will always continue to grow. But we should remember that human creativity will always be needed. As AI continues to evolve, it will redefine how we interact with games, creating experiences that feel more immersive, dynamic, and personal than ever before. Our project is just a small step in exploring how AI can learn and adapt in gaming, but it reflects a much bigger movement in the industry. Thank you for your time, and we look forward to sharing more progress on our project. Thank you.